Hi guys and welcome back. This is our last 15 minutes of the show. I can't believe an hour and a half goes so fast. Competition is now closed. But I think that, an hour and 50 minutes was quite a good enough time to get all of those answers in, and we will be letting you know who the winner is as soon as it's been picked out the lucky hat by our team in the back. I know that there are quite a few questions. Keep them coming. We're going to see how many we can get through with Tamlin and with Buntle. I think what we're going to do now is that Tamlin is going to go over our competition question. Is that right, Tamlin?
Yes, let's go through it and have a look. Right, this one definitely made the mindsetters think a little bit harder
good
today.
Debate, yeah.
Right, okay, so the question asked us, it said that the distance between P and Q, which is the two coordinates given to us, is 10 units, and the midpoint of PQ is, and we had the three options that we needed to find and decide which one is the midpoint. So before I give you the answer, let's actually work it out for a minute. Okay, point Q, if we've got our Cartesian plane, if this is point of x-axis and my y-axis, point Q is 2 and 6. So let's mark that as 2 and 6. So we're going to point that as point Q. And point P is x and -2. So we don't know what the x coordinate is, but we do know that the y coordinate is -2. So what I'm going to suggest is on my y-axis at -2 is let's draw ourselves a dotted line through that. Can we find a nice dotted line that's going to show up? Okay, let's use a green one. Okay, so we're looking at that line over there as to where x is sitting somewhere on this line over there. We don't know where though, okay? Now what we know is that the distance from P to Q, wherever P happens to be on this line, the distance from P to Q is 10 units, okay? So let's give ourselves an estimated line over here. If I said, if we took a line from P to Q, let's say that that's our point P over there. At this point, we are taking a guess as to where it is. We're just estimating it at the moment. That's point P over there. But let's not discount the fact that that distance from P to Q could have gone in the other direction as well, okay? So we could have said that the distance from P to Q could have been 10 units in that direction, okay? So this is a possible point P, but this is also a possible point P. Give ourselves our pen. That's another possible point P. So we have to now just watch out for that, okay? We know that the distance from P to Q was 10 units, right? So we've got 2 and 6, and we've got x and -2, okay? What we're going to do is this. I am going to, first of all, what we can do is we can work out what the y midpoint is. That's easy enough to do, because if I've got the y coordinates of each of the y value of each of the coordinates, we can work out the y midpoint. So to work out our y midpoint, we're going to say y1 plus y2 divided by 2. You recognize that? Mm. So y1, let's say that that's 6 plus y2, which is going to be -2, and that's divided by 2. We are getting 6 minus 2, which is obviously 4, divided by 2. And 4 divided by 2 is 2. Okay, so we're saying that our midpoint, our y midpoint, okay, the coordinate of our y midpoint is 2, okay? Now, just from that alone, we should be able to look at the three options that we actually have over here and get the answer straight away. The y coordinate of our midpoint, or that y midpoint is 2, which there aren't any other values over there. So at the moment, it's pointing very much towards A being the right answer, but let's just confirm that, okay? We're now looking for the x coordinates, okay? Distance, that's where we're going to go with this. The distance from P to Q is equal to our x1 minus x2 plus our y1 minus our y2, and they're both squared. y2 squared, okay? PQ, which is 10, but don't forget that we're saying 10 squared, okay? So PQ has become 100, okay? Which is equal to, I've got x1, which is 2, minus x2, which is x, plus y1, which was 6, minus y2, which is -2. So that's going to become +2 squared. Okay, so we've got 100. I've got, if I FOIL that out, I've got 4 minus 4x plus x squared. That's going to become 8. 8 squared is 64. And if we solve for that quadratic equation, I'm going to have x squared. I'm going to have minus 4x. Okay, let's say that's going to be 68. And if we subtract 68 from it, if I'm correct, we're going to get -32. Okay, and when we factorize, we've got our x and our x. Factors of 32, 8 times 4 is going to be 32, the 8 being the negative and that being the positive. So I'm getting two answers. I'm getting x is equal to 8 and x is equal to negative 4. Now, Butler, do you agree that it's logical that we would be getting two answers for x here? Because as I said earlier, that distance of 10 could have gone in that direction or it could have gone in that direction. So the reason why we're sitting with those two values for x is because of that. Okay. Now, we said that the y coordinate we're looking for the x coordinate. So let's take, if I had negative 4 as the one possible x value, or I had 8 as the other possible x value, okay? Let's quickly do our sum. x1, which is negative 4, plus x2, which is 2, divided by 2, is going to give us negative 2 over 2, which is going to give us negative 1. The other option is that we had y1, which is x1, which is 8, plus x2, which is 2 over 2. 8 plus 2 is going to be 10, divided by 2, which is 5. And if we go back to our options, 5 and 2 were the coordinates of the midpoint. Okay, so those of you who got A as your answer, well done, you got that right. We're all very, very proud of you. That was definitely one that had to get the cogs in the brain going a little bit there, so well done.
I think that's so awesome.
Yeah.
Now, if whoever answered A, now we just wait to see who the winner is.
Who the lucky winner
Yeah,
is.
so if you guys know that you've answered A, I'm holding thumbs and toes and fingers and everything.
Absolutely.
Yeah.
Okay. I know, Butler, you had a question where you wanted to ask about determining whether circles intersect or not. Okay.
Was that the question from
Yep, yeah, it's from
Tshegofatso?
Tshegofatso. Can you please explain the concept where you have to prove that two circles intersect each other internally, externally, or they don't intersect?
Okay. Let's give ourselves a very basic picture here just to explain that concept. If we had on our Cartesian plane, we've got two circles. If we try to do circles here, we're going to get ourselves, let's put one circle, there we go. So we've got one circle here, and let's put another circle there. Okay, right, so we've got a center over here. Sorry, let's get our pen back. Okay, we've got our circle center over here, and we've got our circle center over here. If you are wanting to prove that there are two circles are touching at one point, okay? Then the way you're going to go about doing it is basically the distance of your radii, the distance of my radius from there to there, plus the radius from there to there, okay? If the sum of the radii will equal the total distance from your one midpoint to your next midpoint, okay? So what we would basically be doing is we would work out the distance from your first midpoint to your second midpoint, okay, as a distance formula sum, and then you would have probably somewhere along the sum had to have worked out the distance of your two radii. Now, if the sum of my two radii is the same as your distance from the one circle center to the other circle center, that's proving that your two circles are only touching at one point, okay? Now, if we proved that the distance, if I take my circle, let's see if we can move it along here. If I take that circle and I push it out a little bit, okay? Then, the distance from here is going to be slightly, let's erase those, okay? So my circle center is now at this point here, and my next circle center, let's say, is at that point over there. Okay. Do you guys agree that if I work out the sum of the radii, that radius plus that radius, okay, is not going to be as long as the distance from the one circle center to the other circle center? So to prove that the circles do not intersect, you would have to show that the sum of the two radii is less than the total length from your one circle center to the other, okay? And alternatively, to prove that they intersect twice, okay, so if we were to take our circle and push it up like so, okay, I'm now going to take my point A and I'm going to take my point B. And the sum of my radii, can't see the black pen, the sum of the radii, so from that radius plus that radius, okay, is going to be longer than the distance from my one circle center to my other. And if they're longer, that's proving obviously that they've overlapped, so they're intersecting more than once.
Thanks, Sekgofatso, because that's like a really important question. You
It
know,
is
as
indeed.
matric, it always comes out. They're always going to take it out. So thank you so much for that question.
Absolutely, perfect. While we have some time, what we could actually do just quickly as an alternative to one of the questions that was worked out earlier, also very common, so if you don't mind me going ahead and just, unless there are any questions that those learners have given in.
No questions so far,
No
but guys, we've still got about 5 minutes. Let's
Okay.
squeeze some in.
I'm going to squeeze something in then over here. I'm going to have a look at this. If we've got, I'm going to take the question that was dealt with just now, which was the rectangle. Okay, bear with me. It wasn't quite, but let's just give ourselves a rectangle, okay? And we've got points A, B, C, and D on all four sides of your rectangle, or any quadrilateral, okay? It could be a parallelogram, it could be a rhombus, whatever it is that we're working with, okay? One of the major properties of a quadrilateral is that you've got the diagonals intersect, okay? So that the midpoint from one diagonal to the other is actually a shared midpoint between the other two sides as well. So therefore, if I was to say that this point over here was -5 and 4, and we were to say that this point over here is +4 and 4, we've got down here, let's just give it a value of, no, that's going to be positive. That's going to be +4 and -2, and let's just say we're working with x and y. Okay, this is obviously going to be a lot simpler than possibly what you would get, but it's more the concept that I want you guys to understand. If we're having to find the missing coordinates of one side of a quadrilateral, a very handy way to remember to do it, okay, is to use your midpoints.
I remember this.
Yes. The midpoint from, oh, I keep getting
like
a
the
black
light bulb
pen
going
there.
ding, ding, ding.
The midpoint from there to there is the same as the midpoint from there to there, okay? Now, I do know what the value of A and I know what the value of C is, so it's very easy for me to work out what that midpoint is over there, okay? If I take x1 plus x2 divided by 2, we're going to get -1/2, so that my x-coordinate over there is -1/2. The y-coordinate, y1 plus y2, 4 minus 2/2, that's going to leave us with 2/2, which is 1. So we're getting the midpoint of -1/2 and 1. Okay, so now the idea is we're going to use the coordinates of B and of D, but we're going to use the midpoint formula backwards. Okay, we know that this x-coordinate here, so x1 plus x2, which is the value of x, divided by 2 is equal to the x midpoint of -1/2, okay? And the y1 plus the y2 divided by 2 is equal to the y midpoint of +1. And what you are then doing is what we can do in each case is just do a bit of calculating and work out what the missing values are. Okay, so bear that in mind, grade 12. It's a very common question that comes up, especially when you've got your quadrilateral in your Cartesian plane, where one of the sides of that quadrilateral is missing. So that's just another way of doing it, using your midpoint formula. Sometimes it's quite a handy one to know. You've got to have all these tricks up your sleeve. You've got to remember these little things. It makes your life a lot easier.
Okay, I just want to say something really quickly because I got something from Sehel. He says, Buntle, you really like it to be in studio. Yes, I know. That's awesome. I've enjoyed this so much. It's helped really a lot. And who knew maths could be so much fun?
Absolutely. I think everyone would enjoy it a lot if they just spent the time with the practice.
Exactly, and also helping each other out. I think that's the most important thing. So guys, if there is anything that you're not understanding, I think it's the most amazing thing that you are able to use this online community on facebook.com/learnextra to help each other out. It's incredible.
Absolutely. If I could we had a question that we were wanting to get through today, which we didn't quite manage to. And I'm not obviously going to manage to get through the whole thing, but we've got a minute left, so I'd like to actually just squeeze it in before we have to go. And that's if we're working with our angle of inclination, okay? This is also something which lands up becoming, it's just one of those sections which a lot of you have a hard time with, okay? The question had a line going like that. It had another line going straight down. These lines were parallel. Find my red. Okay, parallel. And now I must remember. It had a theta over here. We had a theta, and what was it again now? Okay, I'm going to add it in here just so we have something to work with. And there was a theta over there, okay? Now, if you're working with a Cartesian plane and you've got this theta coming up more than once, first thing to know is that it's the same number, okay? So if you're able to solve for one of the thetas, you've got the other one, okay? Now, one of the stories here is that you've got inclination. So to work out that over there, you've got your tan theta equals gradient. But another possibility, another situation is that you've got a right-angled triangle here, okay? So if you're not able to find theta using inclination, don't forget you can use your trig ratios, okay? In this question, you were told to find the distance from there to there, and you were told to find the distance from there to there. So what you had was two sides of your right-angled triangle. You had a trig ratio. You could have found theta. Okay, right, so that's just something to go and practice. It's in your 2011 past paper. Go and have a look at it. It's worthwhile.
Woohoo! Okay, guys, we've got 20 seconds left, and now I can finally tell you who the person is. The person who won the question, you are never going to believe it, but it is Sia Dimortlale. Well done, lady. Please send us your the size of your T-shirt, the book you want to win at learnextra.co.za. Thank you so much, Mindsetters. We had a fantastic show. Thank you for joining us, Buntle. Thank you, Tamlin. Bye, guys.